You know that feeling, right? You turn the page in an exam, see a massive 6-mark question, and your heart just sinks a little. We've all been there. But what if I told you those questions are actually your biggest opportunity to bag a top grade? Well, today we're going to crack the code on a real exam question and show you the exact blueprint for a perfect answer.
So that's the big question, isn't it? How do you do it? Because answering these isn't just about knowing the science, it's about communicating it like a scientist, clearly, logically, and completely. So let's break down how to turn this exact challenge into 6 incredibly valuable marks. We're going to jump straight into it. All right, we are tackling a real question from the AQA GCSE Chemistry paper from June 2023. And we're not just going to answer it. Oh no, we're going to deconstruct it using the official mark scheme as our guide. Seriously, think of this as an inside look, a cheat sheet for exactly what gets you every single point. Okay, here it is, word for word. Plan a method to show that the sample of medicine contains potassium ions and bromide ions. You should give the results of the tests. Now, that last part, give the results, it is so easy to miss in the heat of the moment, but it's absolutely crucial. The examiner's asking for 2 things for each ion: the method, what you do, and the result, what you see.
First up to bat, potassium ions. Now this is a classic flame test, and it is all about spotting a very specific color. Let's get into the precise steps that the mark scheme is demanding.
Now, what's really important here is the level of detail. The mark scheme is so precise. You can't just say, put it in a flame. No way. You have to specify a blue or a non-luminous flame. And why is that? Well, because a bright yellow, luminous flame would totally mask the color we're trying to see. So you see, precision is everything. And here it is. This is the crucial observation. This is the result you must write down to get the mark. When potassium ions are present, the flame turns this really distinct lilac color. Nailing this specific color is absolutely key. So here's the point. You have to connect what you see to what it means. You see the lilac flame, and you state that this confirms the presence of potassium ions. That's it. That completes the first half of the answer. 3 marks down, 3 more to go. All right, on to the second part of our challenge, finding those bromide ions. We're switching gears completely here, moving from a flame test to a totally different technique, a precipitation reaction. So we start by getting our sample into a solution. And notice, the mark scheme says distilled water. That's to make sure no other pesky ions are floating around that could interfere with our test. Then, and this is a critical step, we add dilute nitric acid. This is to get rid of any other ions, like carbonates, that might also form a solid and give us a false positive result. And now for the star of the show, silver nitrate solution. The question actually gave us a little clue, telling us we have a dropping pipette, so mentioning you're using it just shows you're paying close attention. Adding this solution is what's going to trigger the reaction we're looking for. And boom, if bromide ions are in there, adding the silver nitrate causes a reaction that forms this insoluble solid, a precipitate. Now this is where knowing your colors is non-negotiable. For bromide, the result is a distinct cream precipitate. It's not white, it's not yellow. Getting that specific color right is absolutely crucial for the marks. And there we have it. The observation of a cream precipitate is the smoking gun, the evidence that confirms the presence of bromide ions. By clearly stating the method and the result for both ions, you've given a complete, logical, and precise answer that hits every single point in the mark scheme. 6 marks secured. But wait, the exam paper didn't stop there. It followed up with a couple of quick-fire questions about a more advanced way of identifying these ions. These are designed to test your broader knowledge, so let's see what they were. So, beyond the simple flame test you can do in the lab, what's the high-tech alternative for detecting potassium ions? The examiner is looking for a very specific name here. And the answer is flame emission spectroscopy. You can basically think of this as a much more sophisticated, super-powered version of the flame test. Instead of just looking at the color with our eyes, a machine analyzes the exact wavelength of light that's given off, which is totally unique to each element.
Okay, so why bother with the expensive machine then? What's the actual benefit of using flame emission spectroscopy over a good old Bunsen burner and a wire? Well, for this 1-mark question, the mark scheme gives you a whole list of acceptable answers. You just need to pick one.
And here they are. Every possible right answer, straight from the people who do the marking. You only needed one of these to get the point.
You could have said it's more accurate or more sensitive, which just means it can detect even tiny amounts. You could have said it's faster, or even that it only requires a smaller sample. Any one of those would have been a perfect answer.
So, after all that, what have we really learned from cracking this question? Well, it's about more than just remembering the tests, isn't it? It's about understanding the logic of the exam itself.
So what's the ultimate takeaway here? Scoring top marks isn't just about knowing the facts. It's about being precise with your language, saying blue flame or cream precipitate. It's about being logical in how you structure your answer. And it's about being complete, always giving both the method and the result. That right there is the winning formula.
So there you have it, the blueprint for a perfect answer, straight from the examiner's guide. The code is cracked. The next time you face a 6-mark question, don't see a challenge, see an opportunity. You know exactly what they're looking for. Now you just have to show them. Good luck.